Welcome to the session on diving deep into hybrid ECS solutions. My name is Seidel Casing, and I'm a senior developer advocate with the Container Services team here at AWS. After watching this webinar, you'll be acquainted with the different types of environments that are available to you for running your ECS workloads. You'll understand how ECS Anywhere works under the covers. You'll be able to run your own workloads on a hybrid environment using ECS. Let's jump right into what we're going to do today. I'm going to give a short overview of ECS, its history, the benefits, and why our customers love using the service. After that, I'm going to go into the use cases for our hybrid solutions, such as ECS Anywhere and ECS on Outposts, and how ECS provides a solution for hybrid workloads. From there, I'm going to go deeper into what actually happens when you install an ECS Anywhere node and how things work under the covers with a hands-on demo. And of course, I will leave some time at the end of the session for Q&A. Please feel free to drop your questions in the chat during the session at any time. Ready? Let's get started. ECS is a highly available serverless control plane for all your container workloads across multiple availability zones, globally available. ECS allows you to choose where you wish to run your container workloads based on your business needs. There's no need to manage software for the control plane, no security patches that you need to install on a regular basis, and ECS is integrated natively into AWS services. Over the years, ECS has evolved, and the feedback we have received from our customers has driven our investments starting in 2014, when we launched the world's first container service, Amazon ECS. In 2016 and 2017, we released AWS Batch, a fully managed batch processing service, and Fargate, serverless compute for containers, including ECS. In 2019, we launched capacity providers to manage the infrastructure of tasks in clusters, Fargate Spot to run interruption-tolerant ECS tasks at up to 70% discount off the price, and Containers Insights to collect, aggregate, and summarize metrics and logs from your containerized applications and microservices. In 2020, we launched support for EFS, a simple, serverless, elastic file system allowing you to share information between tasks and workloads. Support for Graviton, which delivers the best price performance for your cloud workloads running on EC2, and Copilot, to make it easier for you to deploy applications on ECS. Last year, we launched ECS Anywhere, which allows customers to leverage ECS in both on-premises and cloud environments, ECS Exec, a feature that allows users to run an interactive shell or a single command against a container, and AWS App Runner, a fully managed service that makes it easy for developers to quickly deploy containerized web applications and APIs at scale. If there is one theme to these features, we take over more management overhead so that our customers can focus on apps and delivering value to the business instead of managing the underlying infrastructure. ECS does this on unprecedented scale. We launch on average 1 billion containers per week, 3,000 per second. We run 70,000 API requests per second and help some of the largest companies in the world innovate for their customers, including our own Amazon. Amazon ECS is available in AWS regions across 6 continents. So why do customers choose ECS? Primarily because of the ease of use. ECS allows them simply to go faster. They get to production quickly, as the fully managed control plane allows more resources for application development. Integration with all common AWS services and features like Identity and Access Management, IAM, EC2 load balancers, security groups, Elastic Container Registry, ECR, and CloudWatch. ECS is proven in scale, performance, and security. Best of all is the total cost of ownership. ECS is free. You only pay for the underlying resources used. There is no control plane management overhead. ECS forms the building blocks for various services at Amazon for both AWS and Amazon services. Our service teams in Amazon also use ECS for building their services that you, the end customer, know and use on a regular basis, for all of the reasons that we just mentioned on the previous slide. Now let's dive into hybrid solutions. As we spoke to many of our large customers and ISVs, what we were consistently hearing was a need to operate a separate local container management software in hybrid environments for good reasons. This caused friction within these organizations, non-standardized tools, and operational overhead. Some customers may have a specific purpose to keep workloads closer to them, whether it is data management, security, or simply investments they have in their on-site infrastructure. There are 4 key challenges customers face operating container applications in hybrid environments. They want to simplify and have one consistent toolset across cloud and on-premises. They already have existing investments in infrastructure they need to retire, or in some cases, have to deal with local compliance regulations. And the last is data locality. Take a grocery delivery startup in Turkey that operates globally, including in the United States, but they need to keep their financial information local in the country they are running. Factory floors, production lines, hospitals or labs, hotels and restaurants, cruise ships, automobiles, connector cars, mines, oil gas exploration sites. You also have edge networks, points of presence, or TV or movie sets, even supermarkets and convenience stores. These are just some of the use cases that our customers have for running container workloads in a hybrid environment. This is what the hybrid architecture looks like at a high level. On the left, we have the ECS control plane in the parent region, together with AWS Systems Manager service, which we use to interact and manage the ECS Anywhere nodes. On the right, we have a server or a virtual machine that is hosted in the customer data center or on another cloud provider. On the node, you will need to install the ECS and SSM agents, the container runtime, and with those, you will be able to run your ECS workloads on-prem. Going into a bit more detail, let's see how the process of registering an ECS node into the cluster works. And we will also see this in the demo as well. First things first is to generate an activation code on the ECS cluster to add an external instance. This code can be used for multiple activations for the same cluster. Then, install the SSM and ECS agents on the server, which is done through an install script. By sending the relevant information, including the activation key during the install process, the nodes receive short-lived IAM credentials and use these credentials to register the ECS agent into the cluster in the parent region. Now that the node is registered with the cluster, the ECS agent opens a connection through a WebSocket to the API endpoint in the region. When I want to start and run a workload, I go to the ECS console. In the region, I issue a command to start a task. The ECS agent receives updates and actions from the cluster, provides progress, feedback, and metrics back to the region to report on workload health and status. In this demo, I will simulate a customer data center with a server running Ubuntu operating system. The customer wants to run an ECS workload on-prem. I will go through the ECS cluster creation, register an external instance, create a task to run the workload on the new node, and dive into some of the metrics and insights that ECS provides for my running container. So let's dive into a demo. Here I have the console open, which I'm going to log into my worker node. In this case, it's an Ubuntu machine running on an AWS instance in a different region from my ECS cluster. Local IP address, no Docker installed. It also has a public IP, which is accessible from the outside world, as you can see. I'm going to go into my ECS console and create a cluster, which will be the management for our ECS Anywhere node and additional nodes in the future. I'm going to be using a networking only. I gave the cluster a name. I'm not going to be creating a VPC because there are no nodes running in AWS, and I'm going to enable container insights, which will give me more information, and we'll see what this gives me later on throughout the demo. Let's have a look at the cluster. Standard cluster, nothing very much here, no services, no tasks, and I'm going to register my worker node. In this case, it's going to be my EC2 instance running in that Ubuntu instance we saw before. In order to do that, I have to click on Register External Instances. Please be aware that if you do use ECS Anywhere, there is a pricing impact. I have a parent region, which is running in this case in US West 2. I can configure how long this activation key is valid for. I am going to use a role. I can create a new one, which AWS will create for you, or I can use one which I've already created before called the ECS Anywhere role. And that role is made up of two managed policies. First one is the Amazon SSM Managed Instance Core policy, and the second one is the Amazon EC2 Container Service for EC2 Role policy, which gives the permissions, to the machine running to allow it to interact with AWS and run everything which I'm going to be showing in this demo. I can configure this activation code to be valid for a number of activations, in this case 10. Here I'll get my commands, which I need to copy and paste them in my node. I'm going to copy these onto the side, and we are going to jump back into our virtual machine or our instance to see how this actually works. Click Done. So I'm going to log back into my Ubuntu machine, and all these commands have to be run with elevated privileges. So I am going to sudo into root. And the first thing we're going to be doing is downloading the ECS Anywhere install script to my local machine. And let's have a look and dive a little bit deeper into what actually is inside the script. So the script is made up of a number of different functions which download software, install software, for example, installing Docker, set up the correct configuration for ECS exec, installs the ECS agent, shows license, etc., etc. It is a bash script with a number of different parameters which we need to be provided, but simple, easy to read, and readily available for you to go through and see exactly what is running inside. When I run the install script, I need to provide a number of parameters. The first one is the region which I'm connecting to. The second is the name of the cluster which I'm connecting to, an activation ID which I got from my register instance, and an activation code. We're going to run through the installation of the script. It won't take too long, just to highlight a number of things during the process. First thing is, of course, updating a number of packages if needed on the machine. Once that's done, it will install the SSM agent. In my case, it won't install because it's already installed. This is running on an EC2 instance in Frankfurt region. And it registers the instance into Systems Manager, Fleet Manager. Continues through to install the software needed to run the containers. It's going to download all the software for Docker, install all the dependencies underneath. Set up additional software. Certificates for SSL for ECS exec. Number of binaries. install the ECS init, which sets up the software to allow the ECS agent to start. And starts the ECS agent. It's registered successfully, provides the open source licenses which we'll use for these packages. And if I just check which services are running here from Amazon, you'll see, for example, on this machine is now running a systems and SSM agent running on this machine. And essentially, I don't really need to interact anymore through a shell to the machine because everything else from here can be managed through the AWS console. So let's jump over onto the other side and continue from there. The first thing I'm going to do here is create a task definition. The task definition is the configuration of my workload, which container, all the settings and data which is needed in order to run the container. I'm going to choose external, give the task definition a name. In this case, demo anywhere task. It's going to be running with the compatibility of external because it's running on an ECS Anywhere node. I can give it a role. I choose a network mode. In this case, it's either going to be bridge, host, or none. Bridge will be NAT. Host will be mapping port one-to-one port mapping on the host itself. There is no AWS VPC network mode because AWS VPC network mode is not supported on ECS Anywhere. I am going to set in the configuration for memory and CPU for this specific task. And add the container. Give the container a name. Nginx in this case, very simple. Sorry, Nginx container. And if I could type correctly, it would be better. The source of the image, I'm going to configure or provide my port mappings. In this case, it's going to be port 80 to the host of the container. A number of other settings or configurations I can set for a regular container. And I click on create, and here's my task definition. Let's go back into the cluster and look at what we have for the ECS instance. We will see now that we have a managed instance, a new ECS Anywhere instance with a ID of MI with a string. This is the managed instance. If I click on it, I will be taken to the Systems Manager console, Fleet Manager, and I can interact directly with my node running in my data center on-prem through Systems Manager. I'm going to switch to Bash to get pretty colors and elevate my privileges. And let's have a look what's running here on this node. You can see that there is a container, an Amazon ECS agent, which is up and running on the node, which means the ECS is actually running as a container on the machine, not as a service. Have a look exactly what is inside with a little bit of an inspection and dive into what's inside this container itself. Regular metadata. One thing which I do want to point out, and you will see very soon, is there are a number of volume mounts within the container, mounting specific directories from the host machine into the container itself. One of them is a credentials. We'll have a look at what that is in 1 second. Nothing very much else which is interesting, or I would say enticing to the eye. And let's have a look what's inside that mount that we saw before. So here we have a AWS credential file. This is the credentials which the node uses in order to communicate with AWS services. It is rotated on a regular basis, which provides additional security and no long-lived credentials, which can be exfiltrated and used maliciously. When I want to look at what's happening on a machine, I usually dive into the logs to see or the log directory, and I see that there are two different things which catch my eye here. eye here, which is the Amazon directory and the ECS directory. Looking at the Amazon directory, I will see this is the directory for the logs for the SSM agent, which are currently running. Provides all the information on what's happening from SSM. And the other one is the ECS directory, which I will jump into and have a look. Let's see what's inside there. Inside the ECS directory, we see three entities: the agent log, the init log, and the exec folder, which exec will provide the information for all the actions which are performed from the user with ECS exec. We look at the ECS init log. This provides the information of what happened, how the service started correctly. And you can see in the end, we have a container ID. We have the ECS Elastic Container Service Agent, which is up and running. The more interesting stuff, I think, lies in the ECS agent log. So let's have a look and see what we can find over here and what this tells us about what's happening. First thing I want to point out is everything is credentials are rotated from that mount, which is on the host, rotated on a regular basis. You can see the credential in the beginning is using a QH at the end. And we'll see very soon, shortly afterwards, these credentials have changed on a regular basis for the short-lived credentials. We can see that the ECS agent opens up a WebSocket to an endpoint located in the region and has a continuous conversation to pass the commands what's happening between the status on the node itself and what it needs to do, getting those commands and operations from the ECS cluster in the region. So let's start a task and start a container. I choose my task, run a task, choose external because we're working on ECS Anywhere. I'm not going to choose anything connected with an AZ because this is on-prem, not connected with Amazon availability zones or AWS availability zones. And I'm going to run my task. Before I run my task, hold on 1 second. I want to go and have a look at the log. We'll tail the log to see exactly what happens, because for me, this is the easiest and the best way to understand what is exactly happening on the machine and how things work. So I'll just put in this tiny marker and we go back into our console and run the task and switch over to the log itself. The first thing is it'll wait for a certain amount of time to see if there's anything previous steps to complete and start receiving through that WebSocket commands of what I need to do on my node in order to start what ECS wanted me to run for my task definition. It pulls a container. It starts a Docker container on my node itself and reports status backward and forward to the ECS control plane, including metrics of how long things took, when they started, when they stopped. So we can also measure those with inside the console itself and in the control plane. One last thing I want to point out that you can also see it starts streaming metrics for the container through the ECS agent back to the control plane in order for us to monitor what's going on inside my application. And we'll have a look and dive deeper into that in a few minutes towards the end of the demo. If I want to stop my container, and jump back into the log, we'll see commands through the WebSocket, through the conversation and channel which is open, got the commands from the ECS control plane, and the ECS agent on the machine went through and stopped my container. You can, of course, run this as a standalone task, or you can create a service which will manage the scale up and scale down. So I am going to create a service called Nginx service. I'm going to configure number of tasks as 1. Again, choose the right placement next, next, and 8. And jumping back, we'll see the ECS agent with its conversation and session, communicates to the control plane, starts getting the information what it needs to run. One thing you will notice here is there's no real mention of the service definition, because when the agent communicates with the control plane, it gets the information of what Docker container I need to run. The concept of services doesn't really exist in the Docker software here on the node. So everything from that logic and configuration is managed within the control plane within ECS in the region itself. I will see if I look what's happening with the Docker. I can see that I have a previous Docker container which was running before, which is no longer running, and the new one which I just started with the service, which is now up and running, mapping with the ports of port 80 from the outside IP address to the container. So which in theory means if I would open up a browser to my public IP address of my node, I should be able to get the Nginx software, which of course happens. And of course it was planned to do that, but still good to see this actually works. And everything is working as configured and as expected. But let's jump into the service itself and look what we can see from the console. I can see my number of desired tasks, number of running tasks, the launch type. And if I look on my ECS instances, I will see if the agent is connected, if it's active, how much memory is being used by my tasks currently, which is reported from the ECS agent back into the control plane. And Systems Manager will allow me, above and beyond connecting, will allow me to manage the software of this node itself, get information, performance counters, processes, a full management system that you can use if you want on these instances on virtual machines as well. The last thing I wanted to dive in today is the metrics. Here we can see basic metrics for the actual cluster, which is not very much at the moment. But the thing, if you remember correctly, when I created the cluster, I also enabled something called Container Insights, which enables us, or you, the customer, to get better insight, and hence the name, into what's happening with inside your workloads running on your ECS clusters, services, and tasks. When I click on the Container Insights, it takes me to CloudWatch, which is the monitoring and logging console from AWS, managed service. And if you scroll down to get to Container Insights, you will be taken to the location where we can get a little bit more information. So I'm going to limit the scope slightly, and I'm going to dive into my ECS cluster called ECS Anywhere demo cluster. And from here, I can drill down into what's happening. I can see CPU utilization, memory, network utilization, how many instances of containers, how many tasks. Currently, this is pretty much idle because nothing is really happening. So in the background, you're not going to be seeing this. I'm going to start loading traffic onto my task, my container, by hammering the endpoint. And we should be able to see that something starts happening eventually after I generate traffic. And you can see the traffic and metrics, which are all coming from the ECS agent running on-prem in my virtual machine, in my data center, or wherever it may be. CPU utilization, memory utilization, you can get the drill down per cluster, per service. In other words, get insight into multiple services and see how they're performing. In this case, I only have one, so everything is running through this single Nginx service. And also I can drill down, if I would like, by task. And see how my tasks are actually performing and what is generating traffic. Pretty good throughput. The last thing I just wanted to show you is you can also see a visual representation instead of just lines and graphs per entity by using, instead of performance monitoring, we have something called a cloud map, I think it's called. Correct? A container map, I'm sorry. A container map will show me a visual representation of my infrastructure running within my environment. And of course, this can be drilled down and filtered per cluster, per service, per container. You get all the information. I can see a visual representation of what is happening, how things are connected, how each of them are performing. I can drill down into each and every single one of the pieces of the infrastructure to show you where you might have hotspots or cold spots or problems within your infrastructure if there's anything wrong. And of course, filter based on memory, based on CPU. And when drilling down, and of course, into one of these specific entities, you would get the correct metrics and dashboards, graphs for that. That ends the demo, and let's dive back into our presentation to continue. Using ECS Anywhere is highly scalable. All you need to do is add more nodes, register these nodes into the cluster, and manage your tasks the same way you do in the cloud. This can scale, of course, to multiple sites in multiple locations, allowing you to grow along with your business. ECS Anywhere is not the only solution that we offer for our customers. You can use AWS Fargate, our serverless compute service, or Amazon EC2. And for our customers that have hybrid workload requirements, they can choose between ECS Anywhere or AWS Outposts. Let's recap what we did here today. I went into the different architecture patterns and the customer use cases for running your hybrid workloads. I dove into how ECS Anywhere works, what components are needed, and how they interact with each other. I also demonstrated how you can run hybrid workloads with ECS on existing hardware in your data center. So what is your call to action from the session? Try out ECS Anywhere. Gain the benefits of a seamless operational experience for your container hybrid workloads. You can try this out in our self-paced ECS workshop, which is located at ecsworkshop.com. Also, check out the deep dives on our YouTube channel, Containers from the Couch, where we regularly dive into container topics and new releases. Thank you for joining us today. Please leave your feedback on the session. We take the feedback very seriously to continuously improve and provide you a better experience. My email address and Twitter handle are here on the slide. Please feel free to reach out with any questions you might have. I am now going to open the floor to Q&A.